Papa Bale. And welcome to the channel. Alright, let me hook this up on the tripod. Here we go. Hello, Mohammed. What's up? How's it going? Yeah, this is well, yeah, some people might learn something from it, but it's pretty straightforward. I'll give you an up close of the SSG. Maybe that'll help. But I found that this pulse motor can do a lot of things at the same time. Let me move this up closer because I can't really yell or talk loud, so. Okay, so first thing it does is it's a motor. So like if I hooked a fan to the rotor here, let's turn on the power. And currently we're drawing power from the wall. We could use this battery though. I might change that later on. But this meter is the battery, this battery. This meter is for this. I'm going to call it a cat bank. And the cat bank is hooked to the battery to charge it. So it's charging this battery. Then the output, and that's hooked to the trifilar coil. So this is just hooked to the third strand. I'm charging the battery with the third strand of the trifilar. So the coil is 20 gauge, 22 gauge, and 30 gauge, about 666 turns, 700 turns. It's right in there, 730 turns, we'll call it. Of 20, 22, and 30. And the 22 is what's hooked up to this right now. So the charge rate of this is amazing, considering it's not directly hooked to the output. Now the output is hooked to the solid state drive over here. Okay. We got some lights hooked up to that output as well. So the top coil over here is hooked to these lights. All right, so it's already up a percentage. Was at 12.93, now it's at 12.94. And that's just from the extra wire that's in there. Oh, the rotor that I'm using, it's got gyroscopic magnet holders. All right, so let's turn this one on too. All right, with the 2 light bulbs in there, it's generating 1.1. That's probably the rotor too. It's probably just working actually. All right, so this needs 2 things to work. It needs a power supply and it needs a frequency or a pulse rate in order to generate electricity. Now it's getting its pulse rate. Huh. There we go. Well, it's a battery charger. It's a motor. It has extra electricity to light up a light bulb or 2. See what else does it do? Well, right now I think it runs a motor. It runs a solid state generator and gives us its frequency. But what is it? I guess it's a pulse motor hooked up to a bunch of different stuff, doing a bunch of different things. Like I said, it's charging a battery. Let's see what the rate is at that battery right now. It was at 12.94. Now it's at 12.96. And I'm using that cap bank right there to charge the battery. This right here. And I'm using the output to run the 2 lights over here off of this top coil. All the energies and stuff goes into the bottom coil, and then the EMF of the bottom coil, gives you the electricity on the top coil. And what does it do? It's satisfying to put something like this together and have it all work. It's thumbs up, man. And this rotor in the center here, let me turn this off real quick. I'm going to put another rotor on there, but this rotor is really smooth. I mean, it's tight. So it has these gyroscopic magnet holders in it. Pretty neat. Yeah. Are you talking about the relay? Well, I can't hook up the relay just right now, but maybe do it in the future. For sure. I'll hook it back up. All right. This rotor is awesome. I mean, it's literally magnet to magnet. They're like edge to edge. And there's 12 on here. North, south, north, south. And the fact that they're these little flat magnets means I can put this like all the way up there and it's not gonna collapse on me via the cores. that's good. Move this up here. So let me think here. What do I need to hook the battery up to the power? Well, let's unhook the power supply. Oh, right here. Here we go. Perfect, actually. Well, we can do this. We can run it with the battery and see what happens. This is my first time running it on a battery. This whole setup. So let's see what happens. We got our lights. So that means this half is working off of this half. It's awesome. Oh, we're gonna have to, but this one isn't hooked up to anything else, this side. Awesome. So we got more voltage over here. We got 3.3 with the 2 light bulbs. So I bet if I unplugged out those lights, we'd get about 20 volts. All right, so if I could draw like a pathway for you of what's going on, where it's starting. All right, so this is the power input for the SSG. And it goes in and it comes out 2 ways. It comes out from the output, and there's output through a trifilar strand in the coil. And I'm using that, it's at 13 right now, so I think I'm gonna cut it. Wow, it's going up fast. Whew. Yeah, that's the problem with having batteries that are all the way charged up. But when I cut that battery power, if you were looking at the lights immediately got like halfway dimmer because the trifilar strand is working as a transformer with the other 2 strands. And then it's like the magnet hits the trigger coil and you get a little pulse. And that pulse is channeled to the output, I would imagine. So, I mean, huh. This thing charges batteries very, very well. Thumbs up, man. This thing is awesome. You can get one at Amazon. Let me break it down for you. You get an AC cap on the way in. Then you get a bridge rectified. And then you get it going. You send it through 5 different caps in series as the DC is smoothed out. So when it comes out this end, I'm literally charging the battery with it like this. It's great, and it's literally coming off a 22 gauge strand. So it's like not it's not a lot of electricity generated by the magnets. It's more the transformer, the 20 and the 22 being so close together in gauge. Because they are the same length. So then them being so close in gauge, it's like almost a 1-to-1. And that's good. That's good. Those are good odds. So we're not gonna turn on this, the booster coil this time. All right, so we got a burst of electricity from that. Those lights flickered. So this is the coil that's got all the action, and it's 12.97 on the battery. Let's see how long it takes to get to 12.98. But yeah, definitely. Oh, there it is, 12.98. And this rotor is so smooth. It's 12 poles, and it's awesome. It's not I like to call it the conjured pole. So like on all my 6-inch rotors with 4 magnets, and they're all facing north out, right? So in between them, you get a south pole that actually sticks out far enough to use on your rotor. It actually sticks out beyond the rotor a little bit, like it's pushed outward, and so you get a north-south interaction, even though all your magnets are facing one way. So, that is good. From what I hear, having a north-south arrangement is what you want, especially when generating electricity. Like, it's definitely what you want. You can't even hear it. I mean, it's so quiet, it's so smooth. SSG likes it, Like if this little light turns on your SSG, you need to like add resistance or something. You gotta change it up, because you gotta have your output connected before you start it up. And you gotta it's good to use batteries. So this is we're at 12.99 now. And once it gets up to this range right here, 12.99, 13 volts, it slows down a lot. And then also the benefit of using a battery is you get the spike. I think you have to use a battery to get the spike, to charge the battery with the spike. I think without the battery, you don't have a spike. From what I gather, you have to use a battery in order to get the spike. And I'm not utilizing the spike currently. I'm using an SSG that doesn't have a generator combo on it. And there are literally 0 amps being drawn from them. That can't be right. I hope my bench isn't broken. Oh no, we're going from the battery. I don't even know why this is on. That's nuts. I was like, well, it's on because but then I looked and I'm like, oh my God, we're using the battery. And I left it on. That's that's not good. But I mean, it runs so smoothly that I barely know it's running. I could leave it running and totally forget about it. Now I'm thinking that I might put a toggle switch in here so I don't have to keep unclipping the clips. Oh, that's so cool. All right, so we might hook up the relay, but we're going to use this rotor over here. I hope I have enough slack. I might. Man, that was close. All right. It's going to be awesome. All right, that's going to have to be out a little bit. Now, this is very significant how I set this up. So, it's a really dirty habit. All right. So like one of the like laws of battery charging and using is that you're not doing both of them on the same battery at the same time. You can't do that. And especially if there's only 2 terminals to your battery. So there's got to be some sort of swap going on, some sort of, we'll do this at this time and this at that time. Having the coils set up the way they are right now on the rotor at 90 degrees, okay? And then having the magnets at 180, every time it hits a coil, the other coil will be off. On, off, on, off, like that. No, it'll never be on at the same time twice, or look at what I'm trying to say. So there can be a charge and a spend going on with less, and you're using the rotor to actually set that time. Man, it's all right, man. I think it's cool, and it's cold, so I'm good. Oh yeah, I was undoing that one over there. So it'll be like an 18. This one's been in series the whole time, so I'm undoing that. So I can utilize the 20 gauge strand in this one. Because it's a tri-filer as well. Oh yeah, wow. I'm just going to see if it can run like this. Because I need to get another cap bank. Alright. I'm going to start it slow just to see what we're doing here. Now that's the side one that's on now. Let me turn this one on. Awesome. 2 magnets at 180 degrees and then 90-degree coils. Awesome. And it was charging rather well too. Wow. Everything's just kind of coming together all of a sudden. Everything seems so easy. Those of you who may have watched my stream before know that I'm not always successful with what I attempt to do. All right, it's starting to warm up a little bit. See, so I get another one of those cat banks and hook it to the 20 gauge strand over here. Now I don't know if it's going to have the same effect. Maybe I should check that out. I know there's going to be electricity running through it, so I'm not too worried about it. But I mean, that's awesome. We're charging a battery. We're running an entire solid state setup down to the frequency with the pulse motor. Yeah, we checked out a couple rotors. I really like the Dullarath rotor with the gyroscopic magnet holders. That one's really cool. Just it seems like there's like a lot more potential than there was just a few days ago. Just in the way that I've set it up. I mean, when I found out that this 22 gauge strand was going to be able to charge my batteries, I was happy because that's the secondary. The trifilar strand is what's, quote unquote, the thing that might not be there. Usually it's a bifilar coil of like a thicker gauge for the drive and a thinner gauge for the trigger of the same length. But throwing a third strand in there, like, this is awesome. That's, and it's not, or you call it unanticipated energy. I didn't anticipate that kind of eureka moment. But it's really cool. There's no complaints here, man. It's been fun. Every new thing that I figured out. I still have yet to figure out how to like reverse engineer this circuit. I mean, there's parts of it that I'm having trouble like visualizing. So the SSG still eludes me. I mean, there's a couple things on here that I don't even have any of. So I need to figure that out, and then I'll be able to build it. Because right now, it's like halfway SSG. Let me grab it real fast. All right, so That's it right there. So you got your basic standard connection plus a light bulb. And you got your little toggle switch. I mean, this little thing is, I could, package that. Because it works. It works really good. But I mean, all it is setting it up so the transistor will run. It's not an optimized system by any means. All right. I think I actually have another one of those things. So what happens with the trifilar is you get your transformer effect, and then you get your induction effect from the magnet passing by. And you get that effect from your trigger coil as well. See, like right here, this is where a swap would be useful because all right, we need to switch the charge. This one's down to 1280. Yeah, so it's already charging. That's cool. It's working out. Haven't gone anywhere yet, or anywhere hasn't come to me yet. So that's everything's working out just fine. All right, let me try and find. There it is over there. All right. So it's less than about 400. I'm thinking it'd be better with eight in there, but it wouldn't work the same way. Or I mean, four with the 8 poles. But yeah, we're doing something. We're actually charging a battery that was a little low. We're using a battery to do that, so I don't know if we're really gaining right now. It's brilliant. Seems a bit slow. Just saying, it seems a bit slow. Especially for 2 magnets. 2's supposed to go the fastest, and it's going pretty slow. Now I can't get a reading. Maybe it's dying. Huh. Yeah, we used it as a cat toy, so there we go. 1781 divided by 2. that is rather slow. But I guess to get what we need to get done, we don't need to go fast. Still need to charge that battery though. So, give my batteries a break from being spent on. We'll just charge them up a little bit. I mean, since I don't have a circuit running right now that can utilize back EMF, I mean, SSG doesn't do it on its own, from what I gather. It needs to be like a combo circuit. Lights, man, they're pulsing. Heck yeah, man, that's awesome. Just all the channels that it has to go through to get to the point to get over to that light to begin with is amazing. It goes from the middle here over to the bottom coil over there and this transistor right here, and then that top coil picks it all up and spits it out into the light and stuff. What's up, my brother?
What's up? How's it going today?
Smooth, man. It's going good. How about with you?
I'm pretty good. I'm embracing it. Embracing.
Alright, so I'm gonna get the Dolorath rotor.
That looks sweet though.
Heck yeah. I figured I'd hook the lights up, but it's eating most of the reading that comes through. And so I only get like 3 or 4 volts. But without those lights, I'd be getting 12 to 20. They're 12 volt LEDs. Nice. I wish that my throat would clear and my voice would come back.
Yes.
Yeah, it's annoying. Okay. But this one that I'm hooking up is a sweet rotor, man. It's really cool. Oh yeah. Come on, man. Go. I need to loosen that up a little bit.
So how's everybody doing today?
Yeah, what's up? I'm just trying to get over a cold. That's what I'm doing. How about all of you guys?
I like watching DIYs.
Oh, me too. All right, so each one of these
Yeah.
spins both ways.
Yeah, like and subscribe if you guys like DIY pulse motor experiments. This is awesome stuff.
You got the official thumbs up.
Yeah.
I think that's going to be good. Let's move this coil up. I don't think it's really functioning right now the way I want it to. But it's still working. It's just we're bypassing that coil for some reason.
Bypass. There it goes.
All right, it's on.
That's amazing. Anybody have any questions about that one? Welcome in. Welcome in.
Hello, hello.
Like and subscribe. We got pulse motors, electromagnetism, DIY. Ooh. Yeah.
So that's a very low cost. It looks like it's about 150 milliamps to run this one. Yeah, this meter's up to 100 milliamps now too.
Nice. So low cost, and that motor, does the weight of the rotor matter at all?
Not so much, but it is a heavier one.
Okay.
So it does have flywheel capabilities that are better than, say, a lighter one.
All right.
It, like most of my other rotors, its weight is on the edge or the circumference.
Okay.
I have a few ones that were 100%, but only a few. 100% infill when I printed them on my 3D printer. That's what I'm trying to say.
Yeah, I get that. I've watched you print a few, so I know what you're saying. Anybody have a 3D printer at home?
All right, so we're going to test out the magnetic fields. We're getting a lot of south action. North-south, okay. So they've aligned themselves in a north-south orientation. There's 4 positions on the rotor that are stationary and then 4 that are gyroscopic. And they've arranged themselves in a north-south arrangement. That's cool. But the north is farther back, away from the edge, so it's not solid. I've gotten a lot of great ideas, and I'm going to examine the STL files to see if I can incorporate these ideas. I'll be able to use any coil I wanted But right now, it has to have a core in it or it won't work at all. And it's because the magnets don't reach far enough not to have a core. So it's got to hit that core and then it'll work.
I like it. So the more pieces that you have, the more integral the system becomes, and you need all the pieces in their positions for it to work.
Yeah. Position is definitely a key component.
Like and subscribe. Pulse
Check it
Motor
out.
Mayhem.
Yeah. All right, let me check. All right, so we're at 12.89 on the battery here. Just making sure I got the right ones plugged in, and I do. Oh, I know what the problem is. It's the rotor. Remember how I said the magnets weren't like hitting every time? It's got to be how like less strong the magnets are. Well, I don't know actually. Worst case scenario, only 4 of those magnet stacks are hitting, are being hit by the electromagnetism. So I gotta find something to see 12.89. I'm just waiting for it to turn, and I don't think it's gonna. I don't know which way it's going right now, up or down. I think it's going up though. Oh, look at that. See, the magnetic flux reaches the whole iron core all the way out to here. South pulsing. So yeah, only 4 magnet stacks are hitting. The gyroscopic ones are not interacting with the coil. And it's like right up next to it too. That's one of the things I wanted to. I bet a permanent magnet array would work good with this rotor. But I'll worry about hooking that up in the future.
In the future.
But right now I'm gonna get a 4. This one, my air filter one. But this is a very inexpensive rotor to run. The one that's on there right now. This one, standard, I would say. It's only 5.5 inches in diameter. It's not 6. It's a little smaller than that. It's toroidal. Well, you know what I mean by that is that it has a toroid in it, but it's all hooked together. See, this is the flywheel capability that I was talking about. It's like still spinning pretty fast.
Yes, yeah. That's nice work. Good collab designer.
Heck yeah, man. He was brilliant with the 3D printer files. Alright, so.
Sign up for a master membership and you can participate.
Yeah, heck yeah.
Send through the rotor files. We'll print them out and use them in our videos.
We'll send you a copy of your own stuff.
Straight up.
But yeah, definitely, if you got ideas, man, drop me a chat up in, I got a Discord that is available. Just got to go to my page, my channel page.
Yeah, and then the more drop down, gives the links and stuff.
I got my Patreon link. I got all that stuff on the page. Maybe I should put it in the description as well.
And then X for direct message.
Yeah. Oh no.
Nice.
See, now there's nothing on the bottom of this. Okay, there's nothing on here except for some fabric softener. It's just gonna float there. And the bottom of that is iron infused PLA, and it's just gonna float there. That's awesome. The actual balancing that needed to happen during the process of making this, like what had to happen in order to make this, is like, I can't explain it. That much I'm gonna say. I can't explain it. It just happened and it's perfect. So, and it's just, that's its maglev itself. And the magnets are being held in place. That's the awesome part, by the iron infused PLA. And then they're just strong enough to press against the magnet on the bottom. See?
Yeah.
No need to worry about it. All right. Maybe we'll get some sage over here and watch the smoke.
Yeah. You can hear it spinning.
Getting faster, right?
Getting a little faster. The juice. Pump it up. Not too hard. Not too hard.
See, now I'm pumping up the booster circuit, and what it does is make it just go faster. Because the faster it goes, the more energy is generated by the magnetic induction. So the magnet passing the copper, what's generated by that is increased by the speed increasing.
And the lights on the plate are solid now, not pulsing.
Yeah, they're lit up real good. Now let me find out what the frequency is that's pulsing through this top coil right here. Alright, so it looks like an average of about 300 hertz. It dips to about 276 and then it goes up to about 338. Alright, and we're only at 7.8. got about a 70% duty cycle. We're producing 3.8 volts on top of the two 12-volt lights being lit up. So I'd say probably around 15 volts. Between 15 and 20 volts. That's awesome. I mean, if you gather what's going on in this circuit, getting electricity off of this coil is awesome. All right, I'm gonna get the sage.
How's everybody doing today?
Welcome.
This is gonna be cool. Check this out.
Now it's a very slight downdraft above. And if you get in, so it's a first draft basically, and I already can see a way to improve it. Just put some fins on the spokes, because the spokes are already doing the job for you. You just need some fins to direct. Because it's doing both. It's sucking through the center, and it's also sucking around the side. Just like if I put it here, it'll do both. Alright. Got too close. Or something fell off of it.
A little sage fleck.
Yeah.
Yeah,
That's
that's
why I wear my protective eye goggles
yeah.
when I work. Because
That's
doesn't always want to stay put. Yeah. But I think 4 magnets works best for this 12.93. Awesome. See, from way up here, it's sucking it to the outside. Well, most of it. But it's doing both. It's doing both. I can see it doing both, but I mean, I saw it like sucking the smoke around the edge, and I got disappointed. I was like, oh man, it's not. But then I looked closer, and I'm like, well, it's doing both. Sometimes it's just doing the middle. Oh. See, and if I put it out here like this,
Oh yeah, it's blowing.
yeah. See, there's definitely a fan going on here.
Nice. Welcome in, everybody.
Welcome, welcome.
Drop a mic.
So this is the air filter presentation. Yeah, so I slapped some fabric softener on the bottom, and it'll suck it'll suck it right in. And then it does both. It sucks it in the middle here, and then it sucks it around the edge too of the toroidal. So it sucks it on both sides of the toroidal. I don't know even what you want to call it. I just put it in there because I like the shape, like a funny bagel. You know what I mean?
Bagel time.
So what makes this rotor work so well and have its own built-in maglev is the fact that the neodymium cubes are close enough together to form a field in the center that's the opposite pole of the magnet, or the same pole. It's in repulsion to the magnet on the bottom. And then the iron infused PLA holds those magnets, the neodymium cubes, in place. Because you'll find that if you just don't have something to hold them in there, that they'll try and jump out. But other people, that are more ingenuitively inclined than I am, will come up with fantastic ways to do this very thing. And I love watching it, I love seeing it. The little doohickeys are the parts of the machine that actually make it work, that were conjured up at home. The people that made that stuff, thought up that stuff at home and then built it, or the machine needed that part, you know what I'm saying? It was like an integral part of whatever was going on. You know what I'm saying? It happens all the time. It's like just the little things. Like, if you need a diode that goes both ways, then you could solder two diodes together and put a clip on either end, and there you have the two diodes that are going in opposite directions that you can just clip onto something. I mean, I seen it just the other day. It's awesome. So, I mean, those things, I've got mad props. Even for myself, just a little thing that I've done. And it's not, patentable, but this little switch here works pretty freaking good. And it's just, I ran out of transistors, so I needed something to make it work. Well, I was waiting for those to come in, and this is it.
I think it's sweet. The
Heck
homemade
yeah.
stuff. Yeah, and then you get to see the arcing.
Yeah, it's pretty cool. You'd be surprised how important that stuff really is. Super important. So 12.95 on the battery, and we're charging it through this cap bank. So it's like a cap dump, but it's not a cap dump. It's just a filter and a cap bank. Changes AC to DC and filters it, so it's nice and smooth when it comes out the other end. Been charging these batteries with it, and it's been working like a charm, freeing up my SG output to run this motor solid state It's not a motor, it's a solid state generator. Right now I'm lighting up two 12-volt LEDs off of this top coil, so it's all off the EMF of this coil, which we're getting from the output of the SSG. So it's being powered by the output. The frequency, or what's running the trigger on the MPN over here, is this trigger coil. It's hooked up to the pulse motor. So right now it's going through 2 pulses. It's already being pulsed when it's sent through the system here when it gets to this MPN, and then it's being pulsed again through its base. Oh wow. So there's north. Oh. So it's these wires, I'm guessing, that are. Yeah, so there's a strong north magnetic presence around that coil. Huh.
Strong north presence. Magnets.
Yeah, I feel like, well, I mean, the lights are definitely not plugged in very well. Their end is literally like a millimeter of
Alright.
wire.
And then you bumped it a little bit and then it went out, kind of thing?
Yeah, it flickered a little bit.
Alright.
But let's see what's going on with this. Okay. Alright. So I'm going to take the lights out. Or I gotta hook them up again. They're still hooked up, they're just. Here, let's see if that worked. They're just, one of the connections is not good. I don't know which one it is. Huh, no, the other one isn't lighting up at all. That's so weird. Oh. Yeah, the end of that is now underneath the transistor. And I don't want to touch the transistor when it's on. Because you do that and you're gonna make it so it doesn't work as well. There we go. Yeah, that's gonna be a pain in the butt. All right, I'm gonna I'm gonna remove the lights. Then we'll see how much we're really getting. Alright. Now if I want to hook up another light, I'll just hook up one of the big ones. Yeah. Well, it might have been the transistor, because it's not. Alright, so. Alright. Gotta get a. Alright. If there's no change, I'll just put the other one back in. That means it wasn't the transistor. I don't know. I feel like there's this weak connection somewhere, and it has to do with that's it. But we are getting like 3.5 volts off that, but that's nothing compared to what I've seen, so I know something isn't right. It might just be right here. Man, where did I put those? Red and black. Alright, let's change this to a multimeter. Like 12.9. Spin it the other way this time. CCW. Whew. No. I'm gonna hook up, since I don't have another one of those cap dump things, I'm gonna hook up the in-series connection again with that, and I can turn it up higher without it getting all out of control. Huh. Alright, this should be a lot smoother. Now I think why it's so slow is there's a huge load on it right now. this is not right. I don't know what happened. Well, yeah, I gotta make another generator coil anyway. You know, the last one I had, I tried putting an iron core in it, and then it just got sucked into the wheel and thrown across my room. So I'm not interested in like that unless I do it the right way. Just even something as simple as using a core. I mean, you gotta have your everything's gotta be secure. So any innovations in making the wheels secure, your magnets secure, anything that can be launched needs to be secure.
Yeah.
Alright, so we were charging the battery with that, so we're going to charge the battery with the output. We're going to put these clips on, I want to call it a battery pack, but it's not a battery pack. It's a capacitor bank. Alright. Turn this back on. We're at 12.91 on the battery we're charging. Oh man. I heard all that noise and then I was like, wonder what I can do to help with that. No, I don't think this is gonna be a more powerful rotor, but it's definitely gonna be a smoother, more quiet rotor. And then oh wow, yeah, I got that one. Stack a couple bearings up. And it's so cool because you can put this right up next to it. I don't even know. Like, what the lights showed me was that connection wasn't solid, right? So the lights, when they weren't on, the rotor would slow down. So I have to, I might have to have a load on that coil for the rotor to perform well. So if that's so, I'll put one on instead of two. Yeah, that's cool though. It might be this light bulb down here. See, now this coil right here is the remains of like 5 different spools of 32. So might be a bad connection there as well.
Thanks for the likes, everybody.
Appreciate you. So you hear how smooth that's running.
Yeah, that's humming.
Yeah. Heck yeah. And then we've got a few new pieces to the art gallery. Got this pyramid here. Looks like it's got a stone in it. Pretty neat. And then this one, it's pretty smooth. Little souvenir piece from Egypt. So where is the hang up? Oh yeah, and this meter's about to die.
Batteries.
Yeah. Well, there's 6 volts. That's a little better. Maybe it was a connection touching the plate here. Maybe I should get rid of that. I'm not sure. Yeah. That's a way better reading than we had just a second ago. So now I want to try the Dolarath rotor with my permanent magnet stator. Okay, so when a permanent magnet comes around, it'll push it. And because of these two, which will be the main push, it'll gyro. See that?
Nice.
This is a single print. This is awesome. This is a single print. All these things were printed to move. Totally cool. Oh, here we go. 12
Yeah.
AC volts. There it is. I wonder what we did. All right. So now we're getting 12 AC off of the cap bank, I think, right now. And the output of the cap bank is DC, so we're obviously sending it through a coil before it gets read. So it shows up AC. I'm thrilled that we're getting 12, we're basically getting 12 volts off of the third strand on the coil. That's the cool part. You know, 12 usable volts. Off a third strand. That's great. And then the output of the SSG is freed up to charge this battery. Hell yeah. Hmm. Oh, there it goes. There it goes. That's taking a while though off the output of the SSG to get some battery charge going. But we are at like 12.94. Thanks for hanging out though. I really appreciate it. I'm probably gonna step outside and get cool because I'm starting to sweat in here. But yeah, we'll do this again another time. Thank you so much for hanging out. It's been fun. Peace.